Picture this: a vast, uncharted ocean stretching endlessly in every direction. No land in sight, no glowing screen to point the way. Just the creak of wooden planks beneath your feet, the salt spray on your face, and the endless sky above. This was the reality for ancient explorers who dared to venture beyond the horizon, armed with nothing but curiosity, courage, and a handful of rudimentary tools. How did they do it? How did they map the world without compasses, without satellites, without any of the technology we take for granted today? The answer is a testament to human ingenuity, a story woven from starlight, intuition, and the sheer will to discover. Centuries before the first GPS signal ever blinked to life, sailors and explorers relied on the rhythms of nature itself to guide them. They read the heavens like a map, tracking the slow dance of constellations across the night sky. They listened to the whispers of the wind and the waves, deciphering patterns invisible to the untrained eye. They even watched the flight paths of birds, trusting these creatures to lead them toward unseen shores. These weren't just techniques, they were acts of artistry, a delicate balance of science and instinct that turned the impossible into reality. And the maps they created, they weren't just lines on parchment, they were lifelines connecting distant cultures, sparking trade, and reshaping humanity's understanding of the world. What's even more astonishing is how these early navigators didn't work in isolation. Their knowledge was a tapestry woven from countless threads of shared wisdom passed down through generations, across continents, and between civilizations. Polynesian voyagers, Arab traders, Viking seafarers each brought their own brilliance to the art of navigation, creating a global collaboration centuries before the word globalization even existed. Today, we're going to unravel these secrets, to step into the shoes of those who looked at the unknown and saw not fear, but opportunity. By the time we're done, you'll never look at a map or the night sky the same way again. So let's set sail together, back to a time when every journey was a leap of faith and every discovery changed the world. Imagine standing on the deck of an ancient ship, the vast darkness of the night broken only by the glittering tapestry of stars above. For early navigators, this celestial map wasn't just a spectacle, it was their highway, their compass, their unwavering guide. Polaris, the North Star, burned like a fixed beacon in the northern skies, its steady position offering sailors a constant reference point no matter how far they roamed. In the southern hemisphere, where Polaris vanished below the horizon, voyagers turned to the Southern Cross, its 4 bright stars tracing an invisible line toward the pole. But reading the heavens required more than just glancing upward. It demanded precision, patience, and a sophisticated understanding of the cosmos. To translate starlight into direction, sailors used ingenious tools like the astrolabe, a brass disc etched with intricate markings that could measure the angle between a star and the horizon. By aligning the device with Polaris, they could determine their latitude, how far north or south they'd traveled. The quadrant worked similarly, its weighted plumb line and graduated scale turning the sky into a mathematical grid. These weren't just instruments, they were gateways to the unknown, transforming the abstract dance of celestial bodies into tangible coordinates. Yet the true brilliance of celestial navigation lay in its universality. From the Polynesians steering by the rising and setting of key stars to Arab astronomers refining calculations for Mecca's direction, cultures across the globe shared this celestial language. The Vikings, for instance, relied on a sunstone, a crystal that polarized sunlight to reveal the sun's position even on cloudy days. Each civilization added its own innovations, weaving a collective wisdom that turned the night sky into a shared compass. What's often overlooked is how deeply these navigators understood the sky's rhythms. They didn't just memorize star patterns, they tracked the moon's phases to predict tides, noted seasonal shifts in constellations, and even used the stars to mark time. This wasn't guesswork, it was a science centuries ahead of its time, blending observation with intuition. When clouds obscured the stars, navigators fell back on ocean swells, bird migrations, and the subtle hues of sunrise reflecting off distant islands. The stars were their anchor, but their toolkit was as vast as the seas they crossed. The legacy of celestial navigation still lingers today, not just in history books but in our language. Phrases like steering by the stars or finding your North Star echo an era when humanity's destiny was written in the heavens. Next time you look up at a clear night sky, try spotting Polaris or the Southern Cross. You'll be gazing at the same unchanging guides that once led explorers across oceans, proving that sometimes the oldest maps are written in light. When the sun rose each morning, ancient explorers didn't just welcome its warmth, they studied it like a living compass. Unlike the fixed stars of night navigation, the sun was a moving target, shifting position from dawn to dusk. But this movement wasn't a drawback, it was a roadmap. By observing the sun's arc across the sky, sailors could gauge direction with surprising accuracy. One of the simplest tools they used was nothing more than a stick planted upright in the ground. As the sun traveled, the stick's shadow traced a path, shortest at noon when the sun reached its zenith. By marking the shadow's tip at different times, navigators could draw an east-west line, a crude but effective solar compass. The Vikings took this a step further with their legendary Sunstones, clearly cut crystals of calcite or cordierite that acted like nature's GPS. Even on overcast days when the sun was hidden behind thick clouds, these stones could reveal its position. By rotating the crystal until light passing through it aligned in a specific pattern, a navigator could pinpoint the sun's location with eerie precision. Imagine holding a piece of the sky in your palm, decoding sunlight you couldn't even see. This wasn't magic, it was physics mastered by people who had never heard the word. But the sun's utility didn't stop there. Desert caravans and land travelers relied on the sun's predictable rhythms too. The ancient Egyptians aligned their monuments to solar events, while Arab traders memorized the sun's angle at different seasons to cross vast dunes without landmarks. In the Pacific, Polynesian voyagers timed their departures by the sun's position relative to the horizon, waiting for the exact moment when its path hinted at favorable winds. Every culture adapted solar navigation to their environment, turning a universal phenomenon into a personal guide. What's striking is how these methods blended observation with intuition. Without printed charts or digital readouts, navigators internalized the sun's behavior, feeling its shifts in their bones. They knew, for instance, that midday shadows pointed true north in the northern hemisphere, or that the sun hung lower in winter, casting longer, sharper shadows. This intimacy with nature's rhythms turned the sky into a clock, a calendar, and a compass all at once. Today, we might chuckle at the idea of using a stick or a crystal to find our way, but these techniques were anything but primitive. They were the culmination of centuries of trial, error, and ingenuity, proof that humanity's greatest discoveries often begin by looking up. Next time you glance at the sun, remember, you're seeing the same celestial guide that once steered ships across uncharted oceans, a reminder that sometimes the oldest tools are the most enduring. The ocean has its own language, a silent symphony of winds and currents that whispered directions to those who knew how to listen. For ancient sailors, these weren't just forces of nature, they were living signposts as reliable as any compass. Take the trade winds, for example. These steady breezes blew predictably from east to west near the equator, creating invisible highways across the Atlantic and Pacific. European explorers like Columbus relied on them to reach the Americas, while Polynesian voyagers used them to island hop across thousands of miles of open water. But mastering these winds wasn't just about catching a lucky gust. It required an intimate understanding of seasonal shifts, like the monsoons that reversed direction with the calendar, turning the Indian Ocean into a seasonal roundabout for Arab and Indian traders. Then there were the currents, massive rivers within the sea, flowing with such consistency that they could carry a ship for weeks without deviation. The Gulf Stream, a warm current racing northward along the eastern Americas, became a lifeline for sailors returning to Europe. They'd ride its swift waters like a conveyor belt, shaving weeks off their journey. But the real masters of current navigation were the Polynesians. Without written charts or instruments, they memorized the subtle signatures of waves, how the ocean swelled differently near islands, how reflections of lagoons tinted the clouds above them. They could feel the tug of a distant landmass in the way the water moved beneath their hulls, reading the sea's texture like braille. What's astonishing is how these techniques were honed through generations of observation. Viking navigators, for instance, noted how certain winds carried the scent of grass or volcanic sulfur from lands beyond the horizon. In the Mediterranean, sailors learned to distinguish between the cold, dense air blowing off snowy mountains and the warm, salty breezes rising from open water. These weren't just survival skills, they were a form of ecological literacy, a dialogue between humans and their environment. The brilliance of wind and current navigation lay in its adaptability. While celestial methods required clear skies and solar tools faltered in storms, the ocean's rhythms never ceased. Even in pitch darkness or fog, the swell against a ship's side could hint at nearby shores, while a sudden change in wind temperature might warn of approaching land or weather shifts. This was navigation at its most organic, a dance with the elements where every ripple and gust told a story. Today, we've replaced these sensory cues with satellite data and digital forecasts, but the legacy of wind and current navigation endures. Modern sailors still study the old trade routes, and scientists marvel at the precision of indigenous wayfinding. There's a humility in realizing that the most advanced navigation system ever devised wasn't built by engineers. It was woven into the fabric of the planet itself, waiting for curious minds to decode it. So the next time you feel a breeze on your face or watch waves roll to shore, remember, you're witnessing the same forces that once guided explorers across uncharted oceans, proving that sometimes the best maps aren't drawn, they're felt. Before compasses turned the open sea into a navigable grid, the world's earliest explorers clung to the edges of the known where land and water met. Coastal navigation wasn't just a strategy, it was an art form blending memory, mythology, and meticulous observation. Picture a Phoenician trader sailing the Mediterranean 3,000 years ago, his eyes scanning the shoreline for the jagged silhouette of a limestone cliff or the peculiar bend of a river mouth. These weren't random landmarks, they were signatures etched into the collective memory of generations. A single twisted oak on a headland might mark a hidden harbor, while a cluster of sea stacks could signal treacherous currents ahead. The land itself became a living atlas, its contours memorized like family stories. This practice, called piloting, transformed geography into oral tradition. Sailors didn't just note physical features, they wove them into songs and chants, ensuring the knowledge survived beyond individual lifetimes. The Vikings, for instance, had bearing dials, detailed mental inventories of coastal landmarks paired with rhyming verses. A line like "steer toward the mountain shaped like a boar's back" might guide a ship through fog or storm. In West Africa, the Kru people navigated mangrove labyrinths by memorizing the gnarled roots of specific trees, their bark patterns as recognizable as street signs. What's remarkable is how these mental maps transcended mere utility. A distinctive rock formation might be tied to a creation myth, anchoring navigation in cultural memory. The brilliance of coastal wayfinding lay in its adaptability. While celestial navigation required clear skies and ocean currents demanded open water, landmarks worked in any weather. Polynesian sailors used the color of coastal waters turquoise for shallow reefs, deep blue for safe channels, while Norse explorers watched for seabird species that nested only near certain fjords. Even smoke from distant villages or the smell of pine forests carried over water could signal proximity to land. But this method had its limits. Venture too far from shore and the cues vanished. That's why early Mediterranean maps, like the Periplus of the Erythraean Sea, read like narrative travelogues. After 2 days' sail beyond the river's mouth, a bay curves westward where freshwater springs emerge at low tide. These weren't charts in the modern sense, they were stories with coordinates passed down like heirlooms. What's often overlooked is how these techniques shaped human settlement itself. Islands with unique peaks like Sicily's triangular Mount Etna or the Azores' volcanic cones became lighthouses of the ancient world, drawing ships like magnets. Coastal cities flourished where natural landmarks converged, their economies built on the reliability of these visual anchors. Today, while GPS has replaced the need for such intimate knowledge, remnants persist. Modern maritime charts still label promontories with names like Lion's Head or Sail Rock, echoes of an era when the Earth itself pointed the way. Next time you drive along a coastline, try spotting a landmark that might guide a sailor home. You'll glimpse the world through the eyes of those who first mapped it, one shoreline at a time. For ancient mariners, the natural world wasn't just scenery. It was a living, breathing navigation system. Birds, those tireless travelers of the sky, became some of the most reliable guides. Take the Pacific Islanders, who embarked on voyages across thousands of miles of open ocean with nothing but the stars and the habits of seabirds to steer them. They knew that certain species, like the white tern, would fly out to sea at dawn to hunt but always return to land by dusk. By watching the direction these birds took at sunset, navigators could pinpoint unseen islands far beyond the horizon. It wasn't just a hunch, it was a calculated strategy honed over centuries. The Polynesians even had a name for this technique, tilopa, the flickering bioluminescence in the water that sometimes mirrored the flight paths of birds, as if the ocean itself was echoing their guidance. But birds weren't the only creatures offering clues. Schools of fish leaping near the surface often signaled shallow reefs or underwater seamounts, while the sudden appearance of dolphins might indicate a current shift or the approach of a coastline. In the North Atlantic, Norse sailors noted how whales frequented specific feeding grounds, their spouts visible for miles. Following these gentle giants could lead a ship to warmer currents or sheltered bays. Even the absence of life was a sign. A stretch of eerily calm, empty water might warn of a dead zone with no fish, and thus no food or favorable winds. Then there were the clouds, those drifting signposts in the sky. Low-lying cumulus clouds often gathered over islands, their bottoms flattened by the land's heat rising beneath them. A skilled navigator could spot these cloud gardens from dozens of miles away, long before the land itself came into view. At night, the glow of reflected sunlight or moonlight on shallow lagoons called loom sometimes painted the undersides of clouds in pale greens or pinks, betraying the presence of an atoll hidden by darkness. What's extraordinary is how these methods weren't just observations. They were part of a larger, interconnected dialogue with nature. The Maori of New Zealand spoke of the whispers of Tangaroa, the god of the sea, whose movements could be read in the behavior of waves and wildlife. Arab traders navigating the Indian Ocean documented seasonal bird migrations in their logbooks, treating them as celestial events as predictable as the moon's phases. Even Christopher Columbus, despite his reliance on celestial navigation, noted in his journals how flocks of birds led his crew to the Caribbean islands, a moment that changed history. Today, we might dismiss these techniques as primitive, but that would miss their sophistication. These navigators didn't just see animals and clouds, they understood their habits, their rhythms, their unspoken language. In an age where we rely on satellites and algorithms, there's something humbling about realizing that the first global positioning system was feathered, finned, and floating overhead. Next time you watch a bird arc across the sky or notice clouds piling on the horizon, remember, you're witnessing the same silent guides that once led explorers to undiscovered worlds. Now imagine you're in the middle of the ocean, days from any shore, with no birds overhead, no familiar stars visible through the clouds, and no landmarks to orient yourself. This was the terrifying reality that forced explorers to master dead reckoning, a method that combined sheer calculation with unshakable nerve. Here's how it worked. A sailor would first note their last known position, perhaps from a coastal landmark or celestial observation. From that point onward, they'd track every mile traveled by measuring two things: direction and speed. Direction came from the ship's compass or the angle of the wind in the sails, while speed was measured by tossing a wooden log overboard attached to a rope with knots at regular intervals. As the ship moved away from the floating log, sailors would count how many knots slipped through their fingers in a set time, giving birth to the term knots as a measure of nautical speed. But dead reckoning wasn't just about counting knots. It required constant vigilance. Hourglasses turned by crew members marked the passage of time, while the ship's heading was checked and rechecked against the compass. Every change in wind, every shift in current, had to be factored into scribbled calculations on worn parchment. The margin for error was enormous. A miscalculation of just a few degrees could send a ship hundreds of miles off course over weeks at sea. Yet this fragile chain of numbers was all that stood between a crew and oblivion. What's fascinating is how different cultures refined the technique. Arab traders in the Indian Ocean used triangular wooden boards called camels to measure the angle of stars above the horizon, adjusting their dead reckoning with celestial checks whenever possible. Polynesian navigators, meanwhile, incorporated wave patterns into their estimates, feeling the subtle tug of currents against the hull to correct their course. Even errors could become lessons. When Columbus famously misjudged Earth's size during his 1492 voyage, dead reckoning errors ironically led him to the Americas instead of his intended target, Asia. The true test of dead reckoning came during the Age of Exploration, when ships like Magellan's Victoria spent months crossing the Pacific without sighting land. Crews survived on faith in their calculations, knowing one mistake could mean missing a life-saving island by hundreds of miles. That tension between precision and peril is what makes dead reckoning so extraordinary. It was mathematics stretched to its breaking point, a high-stakes gamble where intuition often bridged the gaps in data. Modern GPS might make these techniques seem obsolete, but their legacy lives on. Every time a pilot calculates wind drift or a hiker estimates travel time on a cloudy day, they're using the same principle, moving forward by trusting the numbers when the path isn't clear. Dead reckoning proves that sometimes progress isn't about seeing the destination. It's about having the courage to trust your calculations when all other guides disappear. Picture a navigator standing on the deck of a canoe, no compass in hand, no map in sight, just the vast Pacific stretching in every direction. Yet in their mind's eye, the horizon isn't empty. It's divided into 32 precise sectors, each marked by the rise and set of specific stars. This was the Polynesian star compass, a mental masterpiece so refined it turned the night sky into a grid of invisible highways. Unlike physical tools that could break or be lost, this compass lived in the navigator's memory, passed down through generations in chants and stories. Every star, every constellation had its place and purpose. Arcturus might signal east when it rose, while Antares guided west as it dipped below the waves. The system wasn't just about memorizing stars, it was about understanding their relationships, how they danced across the sky in predictable rhythms over nights and seasons. The true genius of the star compass lay in its adaptability. Polynesian navigators didn't just rely on stars in isolation, they wove them together with ocean swells, wind patterns, and even the flight paths of birds. If clouds obscured the sky, they'd feel the direction of the waves beneath their canoe, knowing certain swells aligned with star sectors. They'd note how the wind tugged at the sails differently depending on which stellar house it blew from. This wasn't navigation by rote, it was a dynamic conversation with the environment where every cue reinforced another. What's astonishing is how this knowledge was preserved without a single written manual. Apprentices spent years learning from master navigators, not just memorizing star positions but internalizing stories that encoded navigational wisdom. A chant about the goddess Hina might secretly teach the angle of the Pleiades at a specific latitude, while a myth about the trickster Maui could encode the seasonal shift of trade winds. These stories turned abstract data into vivid, unforgettable lessons. A mnemonic system as sophisticated as any modern database. Modern scientists have tested this ancestral knowledge with startling results. In the 1970s, the Hokule'a, a replica Polynesian voyaging canoe, sailed from Hawaii to Tahiti using only traditional navigation methods. The navigator, Maupiailug, relied entirely on the star compass and natural signs, and arrived with pinpoint accuracy. Today, NASA even studies Polynesian wayfinding techniques as a model for human exploration in environments where technology might fail, proving that the most advanced navigation system isn't always made of silicon and circuitry. Sometimes it's written in starlight and passed down through the human voice. The legacy of the star compass challenges our assumptions about progress. In an age of satellite precision, it reminds us that the human mind, trained and attuned, can rival the most complex machines. Those navigators didn't just map the Pacific, they mapped the limits of human potential, showing us that the greatest tools are often the ones we carry within. Legends of Viking sunstones sound like something ripped from a fantasy novel, magical crystals that revealed the sun's position even when shrouded by storm clouds. But modern science suggests there's startling truth behind the myth. These weren't enchanted gems, they were likely pieces of calcite or cordierite, crystals with a remarkable property called birefringence. When held to the sky, they split light into two beams, creating patterns that change depending on the sun's hidden location. By rotating the stone until the beams matched in brightness, a navigator could pinpoint the sun's exact position with eerie accuracy, even through thick fog or twilight haze. The brilliance of this method lies in its simplicity. Unlike complex astrolabes or delicate compasses, sunstones were rugged, pocket-sized tools that worked in the harshest conditions, perfect for Viking longships braving the North Atlantic's fury. Historical accounts like the Icelandic sagas mention Solarstein guiding ships during overcast days, and in 2005, archaeologists discovered a calcite crystal aboard a 16th-century English shipwreck, hinting at the technique's longevity. But the real smoking gun came from laboratory tests. Researchers using replica sunstones could determine the sun's location within 5 degrees of accuracy, even when clouds obscured it completely. That's precise enough to steer a ship from Norway to Greenland without ever seeing the sun directly. Debate still simmers among historians. Some argue Vikings relied more on coastal landmarks and bird behavior, while others point to the sheer impracticality of using sunstones during storm-tossed seas. Yet even skeptics admit these crystals could have served as emergency backups when other methods failed. What's undeniable is the Vikings' knack for blending innovation with intuition. Whether gripping a sunstone or reading wave patterns, they embraced every possible advantage to conquer oceans that others feared to cross. The sunstone's legacy challenges our assumptions about ancient technology. It wasn't primitive, it was physics distilled into its most elegant form. In an age where we rely on satellites, there's poetry in realizing that a crystal smaller than a thumb once held the power to guide explorers across uncharted waters. Maybe the Vikings' greatest navigation tool wasn't the stone itself, but the willingness to trust nature's hidden clues, a lesson in curiosity that still lights the way. Ancient maps were never just tools for navigation. They were mirrors reflecting humanity's dreams, fears, and boundless curiosity. Take Ptolemy's Geographia, crafted in the 2nd century, where the known world sprawled across parchment with rivers snaking like serpents and mountains sketched as jagged teeth. This wasn't laziness, it was storytelling. Coastlines blurred into myth, distant lands teemed with creatures from travelers' tales, and the edges of the map dissolved into phrases like, "Here be dragons." These weren't errors, they were admissions of wonder, spaces left open for the imagination to fill. Yet for all their artistic flair, these maps held a deeper purpose. Medieval mapper Mundi, like the famous Hereford map, wove geography with theology, placing Jerusalem at the center of a world shaped like a divine blueprint. Paradise might appear as a literal garden at the map's edge, while mythical kingdoms like Prester John's Christian Empire nestled beside real cities. To modern eyes, this seems fanciful, but to their creators, it was truth, a fusion of earthly knowledge and spiritual belief. The maps didn't just guide travelers, they taught, preached, and preserved cultural identity. What's easily overlooked is how these inaccurate maps still fueled discovery. When Columbus set sail in 1492, he carried maps steeped in Ptolemy's miscalculations, including a shrunken Pacific Ocean. That mistake convinced him Asia lay just weeks away, an error that led to continents unknown. Similarly, Arab cartographers like Al-Idrisi blended Greek science with first-hand merchant accounts, creating maps that guided traders from Cairo to the Silk Road. Precision wasn't the goal, utility was. A map could be wrong by modern standards, yet perfectly suited to its era's needs. The beauty of early cartography lies in its audacity. Without satellites or surveys, mapmakers like Gerardus Mercator later distilled a spherical world onto flat paper, bending reality to fit human comprehension. Even their distortions served a purpose. Mercator's infamous stretching of polar regions made nautical navigation easier, prioritizing function over form. These weren't failures of accuracy, they were triumphs of ingenuity, proving that a map's value isn't just in its fidelity to the land, but in its ability to inspire the next journey. Today, we've traded dragons for pixel-perfect GPS, but something intangible was lost when maps stopped leaving room for the unknown. Those ancient scribbles weren't just charts, they were invitations, whispering that beyond the edges lay not just danger, but possibility. Every crooked coastline and mythical beast was a challenge. Come find the truth for yourself, and in that spirit, they did more than record the world, they helped create it. The Silk Road wasn't just a highway for spices and silk. It was a living, breathing network of shared memory, where every traveler carried fragments of a map in their mind. Picture a merchant in Samarkand haggling over bolts of cloth, his real treasure not in his wares but in the stories he'd collected. The exact bend in the Oxus River where bandits lurked, the smell of sulfur that signaled hot springs near Dunhuang, the caravan stop where the stars aligned over a specific rock formation like a celestial signpost. These weren't written down, they were traded like currency, passed from Mongol horsemen to Persian scribes to Buddhist pilgrims in an unbroken chain of survival. What's extraordinary is how these mental maps defied distance and language. A Tibetan monk might describe a mountain pass to a Nestorian Christian trader using nothing but hand gestures and sketches in the sand, yet the message would travel thousands of miles intact. The Snow Leopard's Leap, a nickname for a treacherous cliff in the Pamirs, would be recognized by Uyghur and Sogdian merchants alike, transcending cultures. This was cartography stripped to its essence, no parchment, no borders, just pure, practical knowledge distilled into landmarks and warnings. The Silk Road's true genius lay in its redundancy. If one route through the Taklamakan Desert vanished under shifting sands, a dozen alternate paths existed in the collective memory of those who walked it. Oases weren't just dots on a map. They were lifelines remembered by the taste of their water. Bitter wells meant danger, while sweet springs meant safety. Survival depended on these nuances, preserved in songs, proverbs, and even the rhythm of camel bells. Caravans moved to chants that encoded distances. 3 days walk to the Red Canyon, then turn where the wind carves stone. Yet these weren't just functional guides, they were cultural artifacts. Persian geographers like Ibn Khordadbeh compiled centuries of oral accounts into the Book of Roads and Kingdoms, while Chinese scrolls like the Ziyu Tajai blended maps with poetry, calling the Tian Shan Mountains the spine of heaven, where eagles carry the prayers of lost travelers. Even the humble prayer flags fluttering on Himalayan passes served as both spiritual offerings and navigational aids, their colors visible for miles in thin air. Modern archaeology has confirmed the accuracy of these mental maps. Satellite imagery shows ancient caravan tracks skirting invisible quicks and pits exactly as described in medieval Arabic texts. The ruins of long-lost caravanserais often align with oral traditions about the place where the moon lingers over twin peaks. It's a reminder that the most resilient maps aren't drawn in ink, they're etched into human memory, adaptable and alive. The legacy of Silk Road navigation lingers today in unexpected ways. The phrase, "to read the wind," still means sensing change before it comes, and the word caravan itself evokes both a line of camels and the shared journey of knowledge. Next time you follow GPS directions, consider this. Centuries before satellites, the world was charted by voices in bustling markets and around campfires, proving that sometimes the best maps are the ones we carry in our stories. Ocean swells move like invisible rivers through the sea, carrying secrets only the most attentive navigators could decode. For Pacific Islanders, these rolling waves weren't just motion, they were a language. Picture a voyager lying prone in the hull of a canoe, eyes closed, fingertips tracing the subtle rise and fall of the water beneath them. A trained navigator could distinguish between the deep, steady pulse of oceanic swells and the shorter, choppier waves kicked up by local winds. But the real magic lay in detecting the anomalies, the way swells bent or bounced back when they struck an island's submerged slopes, creating interference patterns that rippled outward for hundreds of miles. These echoes of land were called dilo in some traditions, a silent signal betraying an island's presence long before it peaked above the horizon. Mastering this art required more than technique. It demanded a kind of bodily intuition, Apprentices spent years memorizing how specific swells felt, the way a northbound wave might steepen slightly when reflecting off a coral atoll to the east, or how a distant volcanic island could scatter the ocean's rhythm into a distinctive crosshatch. The Polynesian navigator Maupiilog described it as listening to the sea's heartbeat, where every subtle variation told a story. To modern scientists, these patterns are now recognized as swell refraction, but to those navigators, they were as clear as footprints in sand. What's astonishing is how precisely this knowledge was applied. Voyagers could detect islands like Hawaii or Tahiti from over 100 miles away just by the sea's behavior. No instruments, no charts, just the trained sensitivity of human perception. The technique was so reliable that during the 1970s revival of traditional Polynesian navigation, the Hokule'a's crew successfully located tiny atolls like Rarotonga purely by swell patterns, despite having no prior visual reference. Yet this skill wasn't infallible. Storms could scramble the ocean's signals and swells shifted with seasons. That's why navigators layered this knowledge with other cues: the flight paths of shorebirds at dusk, the sudden appearance of driftwood or land-nesting seabirds, even the taste of fresh water seeping into the ocean from unseen lagoons. The swell was the baseline, the steady drumbeat underlying all other signs. Today, oceanographers use satellite altimeters to map these ancient pathways, confirming what Pacific Islanders knew centuries ago, that the sea holds maps written in motion. Next time you're by the coast, watch how waves change near a headland or pier. You're glimpsing the same subtle language that once guided explorers across an empty ocean, proving that sometimes the land reaches out to meet us long before we see it. Fire and smoke transformed the landscape into a living signal tower, a language of light and shadow understood across continents. Imagine trekking through the dense forests of North America centuries ago, where a plume of smoke rising in 3 distinct puffs from a distant ridge wasn't just a campfire, it was a telegram carved into the sky. Indigenous nations like the Lakota and the Cherokee developed intricate smoke signaling systems, using damp grass or green branches to alter the density and rhythm of the smoke. A single steady column might warn of danger, while a series of quick bursts could signal a successful hunt or the arrival of allies. These weren't random gestures, they were a precise vocabulary, honed over generations, that turned the atmosphere itself into a messaging system. The ingenuity didn't stop there. In Australia's vast deserts, Aboriginal peoples perfected smoke signals that could traverse hundreds of miles. By lighting fires in specific sequences on high ground like hilltops or rock outcrops, they created chains of communication that relayed news faster than any human runner. The Wiradjuri people, for instance, used smoke to announce gatherings, guide lost travelers, or even coordinate movements during seasonal migrations. The key lay in the context. The same pattern might mean waterhole ahead in one region and avoid this area in another, depending on prearranged understandings among communities. What's often overlooked is how these methods shaped exploration itself. European settlers in the Americas quickly adopted indigenous smoke signaling techniques, using them to mark safe passages through uncharted territories. Lewis and Clark's expedition famously relied on smoke signals to communicate with scouts spread across the Rocky Mountains, a tactic borrowed from the Shoshone. Even the ancient Incas used a network of mountaintop fire beacons, or kulkas, to relay messages along the spine of the Andes, their flames visible from one strategic peak to the next. But the real brilliance of fire and smoke signals lay in their adaptability. Unlike written messages or fixed landmarks, these methods required no tools beyond what the environment provided. A lone traveler caught in a storm could use a makeshift fire to broadcast their location, while entire armies could coordinate attacks across valleys with nothing but coordinated bursts of flame. The system was democratic. Anyone who knew the code could read the landscape, whether they were a nomadic hunter in the outback or a settler caravan crossing the Great Plains. Today, traces of this ancient technology linger in unexpected ways. Modern distress signals still use smoke as a universal call for help, and firefighters employ backburns, a technique indigenous Australians used millennia ago to control wildfires. The next time you see a wisp of smoke curling into the sky, remember, you're witnessing one of humanity's oldest and most resilient forms of communication, a reminder that even the air around us can carry stories when we know how to listen. Long before sailors had polished brass compasses whispering directions, they had something far more mysterious: lodestones, these unassuming chunks of magnetite, found naturally magnetized by lightning strikes or Earth's own magnetic fields, were the original North finders. Picture a Han Dynasty scholar in ancient China around the 4th century, carefully suspending a lodestone from a silk thread and watching in awe as it slowly pivoted to align with the invisible forces humming beneath the world. This wasn't just curiosity, it was the birth of magnetic navigation, a discovery so revolutionary it would echo across centuries. The magic of lodestones lay in their simplicity. Carved into spoon-shaped Sinan needles and balanced on polished bronze plates, they became the world's first compasses, but their use wasn't limited to China. Viking sagas speak of sunstones guiding ships through fog, but some historians argue these could have been lodestones, their pull steady even when the sky offered no clues. Arab traders, too, wrote of the stone that seeks direction, carrying it in hollowed-out wooden floats to keep their bearings during monsoons. What's striking is how these scattered cultures, separated by oceans and epochs, all recognized the same truth, that Earth itself held a secret compass waiting to be unlocked. Yet lodestones weren't foolproof. Their magnetism weakened over time, and rough seas could jostle them into uselessness. Early navigators often paired them with celestial navigation, using the stones to confirm what the stars suggested. This duality, trusting both the heavens and the earth, reveals the pragmatism of ancient explorers. They didn't rely on a single method, they layered them, creating a safety net of knowledge. The leap from lodestones to compasses wasn't instant. It took centuries of refinement, replacing stone with magnetized iron needles, enclosing them in protective casings, adding wind roses for precision. But every revolution starts with a spark, and in this case the spark was literal, lightning striking rock, gifting humanity a sliver of permanence in the chaos of the unknown. Today, we take magnetic north for granted, but those first navigators holding lodestones, they were touching the fabric of the planet's hidden order, proof that sometimes the future hides in plain sight, disguised as a rock. For the Babylonians, the night sky wasn't just a spectacle, it was a meticulously organized ledger. Imagine priests in the ziggurats of Mesopotamia, etching cuneiform tablets with the precise movements of Venus, knowing its cyclical appearances could predict both harvest seasons and safe windows for desert crossings. Their star catalogues, some dating back to the 7th century BC, didn't merely track time, they mapped the rhythms of trade routes. When the constellation Scorpio rose at dusk, caravans knew to avoid the waterless stretches of the Arabian Peninsula until the cooler months. This was astronomy as survival strategy, where celestial patterns dictated earthly journeys. The Maya took this fusion of sky and travel even further. Their observatories at Chichen Itza weren't just temples, they were navigational computers. By aligning buildings with the zenith passage of the sun when it casts no shadow, they could mark the exact days to begin expeditions across the rainforest. The Pleiades cluster, which they called T-Zab, wasn't just a seasonal marker for planting corn. Its position over the Yucatan's eastern coast guided canoe traders to Caribbean salt flats. What's astonishing is how these cultures, oceans apart, independently decoded the same truth. The heavens were a dynamic map, shifting with the calendar. But the real breakthrough came when stargazers noticed something peculiar. The stars' positions weren't fixed. Babylonian tablets record how certain wanderers, planets like Jupiter, looped backward at intervals. This anomaly, later understood as retrograde motion, became a secret weapon for navigators. Polynesian voyagers, for instance, used Venus's cyclical path to calibrate their star compasses, knowing its evening appearance in the west signaled favorable winds for Tahiti-bound voyages. The sky's predictability wasn't just science, it was security. This celestial literacy reached its peak with the Arab world's astrolabe. More than a navigation tool, it was a portable planetarium, its rotating disks encoding centuries of Babylonian and Greek astronomical data. Traders on the Silk Road could hold it to the night sky, aligning its plates to reveal not just direction, but the prayer times crucial for desert travel. The stars didn't just guide them physically, they synchronized spiritual and commercial life. Today, we've digitized the cosmos, but the legacy of these sky watchers endures. Modern sailors still learn celestial navigation as a backup, and space probes use star trackers, direct descendants of those ancient star catalogs. When you check a weather app for sunrise times, you're tapping into a tradition that began with scribes reading the sky's whispers. The real marvel isn't that they mapped the stars, it's that they realized those stars were mapping us all along. History's greatest explorers were never lone geniuses, they were masterful borrowers, stitching together wisdom from every culture they encountered. Take the astrolabe, that ingenious star-tracking device we associate with medieval Europe. Its roots stretch back to ancient Greece, but it was Arab scholars who refined it into a precision instrument, adding intricate plates for different latitudes and detailed star maps. When these tools reached Europe through trading hubs like Al-Andalus in Spain, they revolutionized navigation overnight. Suddenly, sailors could calculate their position with celestial accuracy, thanks to knowledge passed across religious and political divides. But this exchange wasn't one-way. Polynesian navigators who'd mastered the art of reading ocean swells and bird migrations shared their techniques with European explorers during chance encounters in the Pacific. In return, they adopted metal tools and new materials that enhanced their own voyaging canoes. The Vikings, too, absorbed navigation tricks from the Sami people of Scandinavia, learning to interpret the aurora borealis as a directional guide during endless Arctic winters. These weren't just casual trades, they were lifelines, where survival depended on humility and the willingness to learn from anyone who knew the land or sea better than you did. Perhaps the most striking example unfolded along the Silk Road, where Chinese, Persian, and Mongol travelers swapped more than goods. They exchanged entire worldviews. Chinese compasses, initially used for feng shui, became vital tools for Arab merchants crossing featureless deserts. Persian star charts, enriched with Indian astronomical data, found their way into the hands of Byzantine sailors. Even the simple act of sharing a meal could spark innovation. Tibetan caravan leaders taught others to navigate by the taste of grass, sweeter near certain mountain passes, bitter near toxic mineral deposits. What's often overlooked is how these collaborations shattered stereotypes. Medieval European maps once labeled the Indian Ocean as unpassable, until Arab and Malay pilots showed them monsoonal wind patterns that turned it into a seasonal highway. Likewise, indigenous guides in the Americas revealed river networks to European explorers that had been trade routes for centuries. The greatest maps weren't drawn by individuals, they were palimpsests, layered with contributions from countless unnamed hands. This cultural cross-pollination didn't just expand geography, it reshaped human imagination. When Marco Polo returned to Venice with tales of Chinese junks guided by magnetic needles, or when Ibn Battuta described Maldivian sailors steering by the color of coral reefs, they didn't just bring back facts, they brought back possibilities. Every shared technique was a reminder. The world's mysteries weren't meant to be solved alone, but pieced together like a global mosaic, one borrowed insight at a time. One wrong turn beneath the stars, one misjudged current, an entire cruise could vanish without a trace. The ocean was merciless to those who misread its signs. In 1588, the Spanish Armada learned this the hard way when storm winds and navigational errors scattered their fleet across the North Atlantic, dashing ships against Irish cliffs. Without accurate longitude measurements, a problem that wouldn't be solved until the 18th century, sailing east or west was like walking blindfolded. Ships might hit their target latitude, only to overshoot it by hundreds of miles sideways, ending up stranded on uncharted reefs or frozen in Arctic pack ice. The infamous latitude hooks of early maps weren't decorative flourishes, they marked the edges of known safety, beyond which dragons might not be the worst danger. The Polynesians faced different perils. Their star compasses and wave reading skills were extraordinary, but cloud cover lasting days could erase all celestial cues. Oral histories tell of canoes lost in the empty seas, where swells grew confused and birds circled aimlessly. Some never returned, becoming ghost stories whispered between generations. Even the Vikings, with their Sunstones and coastal landmarks, met disaster when fog obscured both. The Greenland colonies likely failed partly because shifting ice made old sailing routes impassable, a grim reminder that nature's rules could change without warning. Yet every catastrophe forced innovation. When Portuguese ships kept wrecking on Africa's west coast, navigators developed the Volta do Mar, swinging wide into the Atlantic to catch favorable currents home. The harrowing loss of Admiral Shovel's fleet in 1707, driven onto rocks by longitude errors, finally spurred Britain's longitude prize. Even Columbus's infamous miscalculation, underestimating Earth's size by thousands of miles, led to the accidental discovery of continents. Failure wasn't just a risk, it was the forge where new methods were hammered out. What's haunting is how many disappearances remain mysteries. The Roanoke colonists' fate, the vanishing of the Dutch ship L'Esperance in the Southern Ocean, these weren't just tragedies. They were unanswered questions that gnawed at the edges of human knowledge, pushing explorers to refine their tools. The bones of lost ships still litter seafloors today, silent monuments to the price of progress. But from each wreck, survivors brought back hard-won lessons. That arrogance drowned faster than any sailor, and that the best navigators were those who listened to the waves, the wind, and the whispers of those who'd sailed before. The stars may have guided ancient navigators, but it was the human voice that kept their wisdom alive. Picture a Polynesian elder sitting cross-legged under a thatched roof. Children gathered around as he chants the rising points of key stars in a melody passed down for centuries. Every syllable, every pause was intentional, encoded not just with celestial data, but with the rhythm of ocean swells and the scent of approaching land. These weren't mere songs, they were living maps woven into the fabric of culture itself. In Micronesia, the wave piloting techniques of the Marshall Islanders were preserved in stick charts, but the real magic lay in the accompanying chants that explained how to interpret their intricate patterns. A single verse might describe how the swell bends around an atoll's eastern reef, or how frigate birds circle counterclockwise before a storm. Half a world away, Norse skaldic poets recited verses that doubled as sailing manuals. The Hafjörðingoljoð, an Icelandic poem from the 13th century, didn't just entertain, it catalogued navigational markers along the Greenland coast, from the sound of icebergs calving to the way northern lights flickered over specific fjords. Viking children learned these verses by heart, internalizing geography through rhythm and rhyme. What's astonishing is how accurately these oral traditions preserved details over generations. When Danish archaeologists compared 19th century Inuit songs describing vanished trade routes with medieval Norse accounts, they found matching descriptions of rock formations now submerged by rising seas. The brilliance of oral navigation lay in its resilience. Written charts could burn or be lost at sea, but a chant remembered by an entire community was nearly indestructible. The Maori of New Zealand embedded star paths in creation myths, turning the sky into a narrative where heroes' journeys mirrored actual sailing routes. A story about the demigod Moi fishing up islands wasn't just folklore, it was a mnemonic for the sequence of seamounts leading to New Zealand's North Island. Similarly, Aboriginal Australian songlines wove navigation into ceremonial music, with each musical phrase corresponding to landmarks across hundreds of miles of desert. Yet this system demanded more than rote memorization. Apprentices spent years learning not just the words, but the subtle inflections that conveyed urgency or caution. A Yupik elder teaching sea ice navigation might lower his voice when describing thin ice, a vocal cue as critical as the words themselves. In the Caribbean, Arawak fishermen still use call and response chants to teach wave patterns, where the leader's pitch rises when indicating dangerous currents. These weren't static recordings, they were interactive lessons, adapting to new discoveries while preserving core truths. The fragility of this knowledge hits hardest in the stories we've lost. When European diseases decimated native Hawaiian populations in the 19th century, entire schools of celestial chants vanished with their last practitioners. Today's revival efforts like the Hawaiian Kumu Hula, reconstructing navigation chants from fragmented manuscripts, reveal how much precision was embedded in these oral archives. Modern experiments prove their accuracy. When researchers compared Marshallese wave chants to satellite oceanography data, the descriptions of reflected swells matched scientific models within a 5% margin of error. What's often overlooked is how these traditions shaped human cognition itself. Neuroscientists studying Polynesian navigators found that those trained in oral star compasses developed extraordinary spatial memory, able to mentally rotate complex star paths as if manipulating 3D models. The act of singing constellations didn't just preserve knowledge, it rewired brains to think in movements and relationships rather than static points. In an age of GPS, that's a reminder that the oldest maps weren't just stored on parchment or in apps, they were etched into the very way we perceive the world, one song at a time. Zheng He's treasure ships dwarfed the vessels of his European contemporaries, their crimson sails billowing over fleets that carried not just silk and porcelain, but an entire worldview. In the early 15th century, when most sailors feared venturing beyond sight of land, this Ming Dynasty admiral led 7 epic voyages from China to East Africa without a single compass malfunction to blame for disaster. His secret, a fusion of celestial navigation, tidal charts refined over centuries, and an innovation called the starboard, a rotating disk that correlated star positions with seasonal winds. But what truly set Zheng He apart wasn't just his tools, it was his willingness to listen. Arab pilots taught him monsoon patterns, while Swahili traders shared secrets of the Indian Ocean's currents. His maps, later destroyed by isolationist emperors, may have charted lands as distant as Australia, proving that ambition could stretch farther than the horizon. Leif Erikson's story plays out in starker contrasts, a lone longship cutting through the North Atlantic's fury, guided by little more than a sunstone and the raw instinct of a man raised on sagas of westward exploration. Around the year 1000, when most of Europe still believed the ocean boiled at its edges, Erikson followed rumors of a land sighted by a storm-blown trader named Bjarne Herjolfsson. With no charts or celestial aids precise enough for such latitudes, the Vikings relied on something subtler: the color of the water. Iceberg melt turned the sea milky green near Greenland, while plankton blooms signaled shallower coasts. When Erikson finally waded ashore at Vinland, modern Newfoundland, he wasn't just discovering America. He was proving that navigation could be as much about reading nature's whispers as following stars. Then there were the Polynesian wayfinders, whose achievements defy belief. Imagine setting out across 2,000 miles of open Pacific in an outrigger canoe. No instruments, no written records, just memory, wind, and waves. Masters of the ETAC system, they conceptualized their canoes as stationary while islands moved toward them along star paths. This mental model, passed down through chance, allowed them to track progress without maps. When Maupiilog revived these techniques to guide the Hokule'a from Hawaii to Tahiti in 1976, he didn't just replicate ancient routes, he silenced centuries of colonial assumptions about primitive navigation. What unites these explorers isn't just their courage, but their refusal to see limitations as barriers. Zheng He's diplomacy, Erikson's grit, the Polynesians' ecological intuition, each forged a unique path through the unknown. Their legacy isn't just in the lands they found, but in the enduring truth that exploration isn't about the tools you carry, but the curiosity you refuse to leave behind. Every time your phone pinpoints your location within seconds, it's standing on the shoulders of millennia of human ingenuity. GPS satellites may orbit 12,000 miles above us, but their digital signals follow pathways first blazed by stargazers and sailors who had nothing but the wind and waves to guide them. Modern navigation didn't erase the old ways, it absorbed them. Take dead reckoning, that nerve-wracking blend of math and intuition used by ancient mariners. Today's pilots still learn it as a failsafe, calculating position by factoring in speed, time, and direction when instruments fail. The Apollo astronauts trained in celestial navigation, practicing with sextants to find their way home if computers crashed. Even the algorithms behind GPS triangulation echo the Polynesian concept of ETAC tracking movement relative to multiple reference points. The past lingers in unexpected places. Commercial airliners carry backup astro compasses, small devices that measure the angle of the sun or stars, nearly identical in principle to the Viking Sunstone. The U.S. Naval Academy still requires midshipmen to master celestial navigation, not as a historical curiosity, but because EMP pulses or cyber attacks could blind satellite systems in an instant. There's poetry in knowing that a lieutenant on a destroyer might plot a course using the same North Star that guided Phoenician traders 3,000 years ago. But the connections run deeper than backup systems. Modern mapping technologies like LiDAR now uncover ancient Polynesian wave pilots, stick charts, or ink and sec lines, alignments of sacred pathways that doubled as navigational markers, proving these systems were far more precise than once assumed. Even machine learning gets in on the act. Researchers train AI to predict ocean currents using data patterns that mimic the way Marshall Islanders read wave interference. The past isn't just preserved, it's being reverse engineered. Perhaps the most profound tribute lies in how we've democratized these age-old skills. Apps like Google Maps may seem worlds apart from Ptolemy's Geographia, but they share the same goal: making the unknown accessible. When you check a hiking trail's elevation on your watch, you're using the descendant of an Inca quipu, not recording mountain passes. When sailors overlay weather data on digital charts, they're replicating the layered wisdom of Arab traders who memorized monsoon winds. The tools have changed, but the human desire to navigate, to shrink the world just enough to explore it, remains unchanged. Next time you glance at your GPS, spare a thought for the generations of navigators who turned curiosity into certainty. Their legacy isn't just in the devices we hold, but in the unbroken chain of wonder that connects a child following a compass needle today to a Viking steering by the glow of a magnetized stone. The future of navigation isn't about replacing the past, it's about remembering how much the past still has to teach us. The Hokule'a isn't just a canoe, it's a time machine. When this double-hulled voyaging vessel set sail from Hawaii to Tahiti in 1976, its crew deliberately left behind modern instruments, relying solely on the same celestial cues and wave patterns that guided Polynesian navigators 1,000 years earlier. The result, a voyage that stunned skeptics and scholars alike. Without a single compass or chart, Master Navigator Maupi'ailug steered the Hokule'a across 2,500 miles of open ocean, arriving with pinpoint accuracy. This wasn't a reenactment, it was a revelation proving that ancient wayfinding methods weren't just theoretical, they were astonishingly precise. What's often overlooked is how these recreations transformed academic understanding. Before the Hokule'a's journey, many historians dismissed Polynesian expansion as accidental, suggesting canoes simply drifted to new islands. But the voyage demonstrated something radical. These navigators didn't stumble upon islands, they targeted them. By reading the subtle refraction of swells around unseen landmasses, tracking the flight paths of homing birds, and memorizing star sequences down to the degree, they achieved feats of navigation that rival modern GPS. When the Hokule'a's crew detected the island of Rarotonga purely by the behavior of ocean waves long before it appeared on the horizon, they weren't just proving a point. They were resurrecting a lost science. The ripple effects of these voyages extend far beyond academia. For indigenous communities, they've sparked a cultural renaissance. Young Polynesians now study traditional navigation in schools, blending star compasses with satellite data to reclaim ancestral knowledge. The Hokule'a's worldwide voyages from Japan to New York have turned its crew into ambassadors for oceanic stewardship, drawing direct lines between ancient sustainability practices and modern conservation. There's profound symbolism in watching a vessel powered by wind and wisdom dock in cities reliant on fossil fuels, a living reminder that progress doesn't always mean discarding the past. Yet the most compelling lesson lies in the failures. During early attempts to replicate Maori migrations to New Zealand, crews discovered that modern recreations often missed their targets by hundreds of miles, not because the methods were flawed, but because contemporary navigators lacked the generational intuition baked into oral traditions. It took years of apprenticeship with elders like Pi'ailug to relearn skills like detecting land by the taste of rainwater or sensing currents through the hull's vibrations. These weren't just techniques, they were sensory languages honed over lifetimes and nearly erased by colonization. Today, projects like the Hokule'a challenge our assumptions about technology and progress. When a storm knocked out its GPS during a 2017 voyage, the crew didn't panic. They simply switched to the stars, navigating as their ancestors had. In an age of climate crises and digital overload, these voyages offer more than history lessons. They're blueprints for resilience, proving that sometimes the oldest ways forward are the most enduring. History loves a good mystery, especially when it comes to navigation, but not all legends survive the test of time. Take the infamous Phantom Islands that haunted medieval maps like High Brassel or St. Brendan's Isle. These weren't just fanciful doodles, they were symptoms of a deeper truth. Early explorers often mistook fog banks, mirages, or even floating pumice rafts for solid land, etching their errors onto parchment with unwavering confidence. The irony, some of these myths turned out to be real. Buss Island, once dismissed as a sailor's tall tale, was later identified as a submarine volcano that occasionally breached the surface, proof that even the wildest stories sometimes hid a kernel of fact. Then there's the persistent myth that ancient sailors never ventured far from shore, clinging to coastlines like nervous children. Tell that to the Polynesians, who crossed thousands of miles of open ocean with nothing but the stars and swells as guides, or the Vikings who braved the North Atlantic's fury to reach North America. The real shocker, evidence suggests seafarers may have reached the Americas long before Columbus, not by accident, but by design. Artifacts like the Maine penny, a Norse coin found in a Native American settlement, hint at transatlantic exchanges that history books barely acknowledge. But perhaps the most stubborn misconception is that early navigation was crude guesswork. Those intricate stick charts of the Marshall Islands, they mapped wave patterns with a precision that modern oceanographers now confirm using satellite data. The so-called primitive astrolabes of medieval Arab scholars could calculate latitude to within a degree accuracy that put European navigators to shame for centuries. Even the Greeks had the Antikythera mechanism, a celestial computer so advanced its complexity wouldn't be matched for another 1,000 years. What's truly surprising is how these myths persist in the shadow of overwhelming evidence. The idea that medieval people believed the Earth was flat, debunked by scholars centuries ago, yet it still lingers, the notion that Columbus discovered America. Indigenous cultures had already mapped continents with oral precision that put European cartography to shame. The real story isn't about inaccuracy, it's about how knowledge was lost, suppressed, or simply ignored because it didn't fit the dominant narrative. Unraveling these misconceptions does more than set the record straight. It reveals the quiet genius of cultures written off as less advanced. When Chinese Admiral Zheng He's fleet dwarfed Europe's ships in the 15th century, or when Incan Quipu knots encoded topographic data as effectively as any parchment map, they weren't exceptions to the rule. They were proof that navigation's history isn't a straight line of progress, but a tapestry of innovation, often woven by hands history forgot to name. The next time you hear an old myth about clueless explorers, dig deeper. The truth is usually far more fascinating and humbling than the fiction. The open ocean didn't just test a navigator's skill, it preyed on their mind. Imagine months without sight of land, surrounded by endless water under a sky that offered no guarantees. The creak of the ship's timbers became a metronome for madness, the isolation so profound that sailors reported hearing voices in the wind. Ferdinand Magellan's crew, starving and scurvy-ridden during their grueling Pacific crossing, resorted to chewing leather and sawdust, their hallucinations blending with the real horror of uncharted waters. This wasn't just physical endurance, it was a war against despair, where the greatest enemy wasn't storms or starvation, but the slow erosion of hope. What's rarely acknowledged is how explorers weaponized routine to stay sane. Cook's logbooks from the 18th century reveal meticulous rituals, daily observations, strict meal schedules, even improvised theatrical performances, not just for discipline, but to fabricate normalcy in the abnormal. Polynesian navigators had their own safeguards. Chants passed down through generations weren't just navigational tools, but psychological anchors. The rhythm of the words, repeated for hours, became a meditative lifeline against the void. Even the Vikings, those icons of stoicism, carved runes into masts and oars, turning their ships into moving shrines where superstition and faith blurred into necessity. The true test came when all systems failed. Cloud-covered skies erased celestial guides, storms scrambled wave patterns. In those moments, navigators fell back on something far more fragile, their own judgment. The journals of Arctic explorers like Franklin and Shackleton are littered with entries describing the agony of decision-making under uncertainty. Do we trust the ice ahead? Is that dark smudge on the horizon land or a trick of the light? One wrong choice could doom an entire crew, and the weight of that responsibility left its mark. Captain Blake, cast adrift after the Bounty mutiny, survived not just on navigational brilliance, but on sheer force of will, transforming desperation into a 47-day odyssey across 4,000 miles of open sea. Yet for all the darkness, there were flashes of transcendent resilience. The same isolation that bred fear could also forge camaraderie. Polynesian legends speak of navigators sharing dreams of distant islands, their subconscious minds piecing together clues missed by waking eyes. Arab traders on the Indian Ocean timed voyages to coincide with the Ramadan fasting period, turning physical hardship into spiritual fuel. Even Columbus, for all his flaws, documented moments where his crew's collective hope defied logic, citing non-existent land in flocks of birds or interpreting rain clouds as divine signs. This psychological dance between doubt and determination, between the mind's fragility and its astonishing adaptability, is the untold backbone of exploration history. We celebrate the maps they made and the lands they found, but rarely do we honor the mental battles fought in the spaces between. The next time you trace a finger along an ancient trade route or marvel at a Viking's crossing, remember, those lines weren't drawn by tools alone. They were carved by the human spirit, one stubborn decision at a time, in the face of an indifferent sea that asked again and again, "How much can you endure?" The answer, it turns out, was always more than they knew. History has a way of whispering only half the story, especially when it comes to the sea. While we picture bearded explorers gripping compasses and squinting at horizons, some of navigation's most brilliant minds wore skirts, not sailors' breeches. Take Queen Hatshepsut of ancient Egypt, who launched the first recorded long-distance trading expedition to the mysterious land of Punt around 1470 BCE. Her fleet didn't just bring back ivory and incense. It returned with detailed accounts of wind patterns and coastal landmarks, etched into temple walls like a Bronze Age GPS log. This wasn't some ceremonial joyride. It was a strategic masterstroke orchestrated by a ruler who understood that trade routes were the lifeblood of empires. Then there's the quiet revolution of Polynesian wayfinding women. While Western narratives fixate on male navigators, oral traditions across the Pacific speak of poet navigators, women who memorized hundreds of nautical chants encoding star paths, wave rhythms, and even the scent of distant islands. In the Marshall Islands, grandmothers wove these secrets into children's lullabies, turning bedtime stories into survival manuals. When European ships floundered in the Pacific's vastness, it was often indigenous women who corrected their course, reading cloud formations and bird behaviors that baffled foreign captains. The irony, many of these contributions were erased not by accident but by design. Medieval Arab geographers like Al-Idrisi openly credited female spice traders for mapping monsoon routes in the Indian Ocean, yet their names vanished from later European translations. Even Jean Barrett, the first woman to circumnavigate the globe in the 1700s, did so disguised as a man, her botanical discoveries overshadowed by her gender. What's lost when we ignore these voices? More than just fairness, we miss the full tapestry of human ingenuity. Women navigators often excelled in areas men overlooked, like interpreting subtle environmental cues. The Haida people of the Pacific Northwest relied on female canoe captains to read tidal rips and kelp forests, skills honed through generations of harvesting shellfish. In Norse sagas, seeress like Thorbjörg Littlevolva were consulted before voyages, their weather predictions taken as divine guidance. The real tragedy isn't just that these stories were suppressed, it's how their absence distorted our understanding of exploration itself. The myth of the lone male adventurer ignores the collaborative reality of historic voyages, where success depended on diverse skills. Next time you see an old map, remember, the blank spaces weren't just filled by men with compasses. They were charted by countless unseen hands, and more than a few held paddles, spyglasses, or the reins of power. From the stars to the waves, early explorers mapped the world with nothing but observation, ingenuity, and courage. Their legacy isn't just about the lines they drew on parchment, it's about the way they saw the world. They looked at a night sky and saw a grid of highways, at a passing bird and read a road map, at a ripple in the water and sensed distant shores. These weren't just skills, they were a way of thinking, a refusal to accept the unknown as unknowable. What's humbling is realizing how much we've lost in the age of GPS. We've gained pinpoint accuracy, but traded away something deeper, the intimacy with the world that comes from relying on it. There's a profound difference between typing coordinates into a device and feeling your way across an ocean by the swell of the waves or the angle of the stars. Those ancient navigators didn't just know where they were, they understood why they were there, attuned to the rhythms of nature in a way that's become rare. Yet their legacy lives on in unexpected places. Modern pilots still learn celestial navigation as a backup. Sailors in remote corners of the Pacific still read waves like their ancestors did. Even astronauts train with star charts, preparing for the day when technology might fail. The past isn't just history, it's a toolbox for resilience, a reminder that the human mind, when sharpened by necessity, can navigate far more than we imagine. So next time you unfold a map or glance at your phone's blue dot, take a moment to think beyond the screen. Behind every route and destination lies a story of a Viking gripping a sunstone in frozen seas, a Polynesian elder chanting star paths to a child, or a Silk Road merchant memorizing the scent of desert winds. These explorers didn't just chart the world, they showed us how to move through it with wonder and grit. If this journey through history sparked your curiosity, let's keep exploring together. Hit like if you want more deep dives into forgotten knowledge, subscribe to join our next adventure, and drop a comment below. What uncharted corner of history should we navigate next? The world's still full of mysteries, and the next great discovery might just begin with your suggestion. Until then, keep looking up and never stop wondering what's beyond the horizon.